Okay guys, now we have reflection and transmission. Let us consider figure 17.9. Okay, we can see, as we can see, there is a pulse or incident pulse traveling on the string towards the wall, and that string is attached and fixed to the wall. Yeah, this is the wall, is fixed to the wall, as in figure A. Okay, in figure B, the pulse is now reaches the support towards the end of the string. So meaning that when the pulse is reaches the support here, meaning that the string ends, and as a result, the pulse undergo reflection, as we can see in figure C. The pulse is moving back along the string in opposite direction. It is a reflected pulse. This reflected pulse is inverted. This is happen. Why? Because when the pulse reaches the fixed end of the string produces an upward force on the support. According to the Newton's third law of motion, the support must exert an equal magnitude and opposite direction of the reaction force on the string. That is why the pulse is reflected. Okay, now we have the second figure here, figure 17.10. Okay. Okay, this is actually for the pulse traveling on the string with free end. Okay, the tension at the free end is maintained because the string is tied to a ring. Okay, this is ring, and the mass of the ring is negligible, and it is actually free to slide upward and downwards vertically on a smooth post. This is a smooth post on a frictionless system. This is frictionless system. There are no friction between the ring and also to the pole. And again, we have here an incident pulse. The pulse is traveling along the string towards the end. And what happened over there? When it reaches the poles on figure B, the pulse exerts a force on the free end of the string, and this will cause the ring to accelerate upward. The ring, as we can see, rises as high as the incoming pulse, and then the downward component of the tension force pulls the ring back down. This movement of the ring produces a reflected pulse that is upward oriented and that has the same amplitude as the incoming pulse. As we can see, the reflected pulse here will go backwards. It's not inverted as what we have in the first case. Okay, alright. So it's not inverted. It's the same as the incident pulse. Okay, right. So that is case number 2. So another one, the last one here. This is actually we have this one, figure 11. Figure 17.11 and figure 17.12, 17.12 and 17.11. We have a string, a light string is attached to a heavier string in figure 17.11 as well as 17.12. So in our case here, when a pulse traveling on the light string, incident pulse, okay, and then reach the boundary between the two strings, the heavier string and the light string. From here we can see that part of the pulse is reflected. Part of the pulse is reflected invertedly, and part of the pulse is transmitted to the heavier string. The reflected pulse here is inverted because what we have discussed earlier, just now. Okay, for the second one, the incident pulse is coming from the heavier string, and when it is encountered, the connection of between heavier string and the light string will have some of the pulse being reflected, and some of the pulse will transmit into the string. And the reflected pulse here is not inverted like what we have in the 17.11.